Here's a crash course on everything electric charge and forces. Electricity is dictated by atoms. Though atoms don't look too much like this, they look more like this. That's a nucleus in the middle there, and he's surrounded by all of those electrons, forming something known as an electron cloud. Now, electron clouds carry charge, which is good because without charge we'd have no electricity. Each electron is carrying what's known as the elementary charge, which is equal to 1.6 times 10 to the negative 19 coulombs. They're not the only particle doing this, so are protons, which are positively charged. Because they're positively charged, their final charge is going to just be 1.6 times 10 to the negative 19c. Because electrons are negatively charged, they're the same thing, just negative. Pretty simple. What's even more simple are neutrons. With no charge, they don't use the elementary charge. They're not positive and they're not negative, they're just neutral. Protons and electrons can react with each other in the same way that the two poles of a magnet do, in which positive charges and negative charges attract each other, whereas positive to positive charges and negative to negative charges would both repel. Materials that allow the flow of charge through them easily are known as conductors. A good example of this would be the copper wires probably in your walls right now. However, insulators are materials that don't allow the flow of charge through them easily, a good example being a rubber eraser. The flow of charge can be represented by Coulomb's law, in which the magnitude of the electric force is equal to Coulomb's constant. That's that number right there. It's going to be that number times charge of particle 1 times charge of particle 2 divided by radius squared, in which radius is the distance between the center of the two particles. The electric force of this is really strong. Think about it, it overpowers gravity. Put a magnet on your fridge and it's not going to fall down. It can be represented by something known as an electric field. If we were to take this person right here and draw an electric field for it, it's going to look like this. It's got arrows pointing out in every direction, showing exactly where and why something would interact with it. If we were to drop in a little electron for it to use, it's going to look like that. A good rule of thumb is, if something is positively charged, its electric field is going to point away from it. If it's negatively charged, the field's going to point towards it. We can see that right here, in which all of the field lines are pointing towards the electron and away from the proton. Because of this, we can also see exactly why they're attracted to each other. The proton pulls itself towards the electron. This can all be shown via the electric field strength equation, in which the electric field strength is equal to Coulomb's constant times the charge of a particle divided by radius squared, with radius being the distance from the center of the particle to anything dropped in its electric field. You can use this to find out how anything would interact with anything, anywhere. And if that's not pretty cool, I don't know what is.